Hi. Today, we are going to talk about AI ethics. Think of this as the part of AI that keeps your code from causing real-world trouble. When we build models, we normally ask questions like, what is the accuracy? How fast does it run? How big is the model? AI ethics adds new questions on top of that. Who is affected by the system? Can it hurt someone if it fails? Is it fair to everyone who uses it? As future engineers, you will work on systems that touch real people, not just benchmark datasets. So this session is about learning how to design AI that is not only smart, but also responsible, safe, and something you are proud to sign your name under. Let us start with a clear definition. AI ethics is the study and practice of how AI systems should be designed, used, and controlled in a responsible way. It connects three pieces that always go together. First, technology, your models, your data, your algorithms. Second, people, not only the users, but also everyone who is impacted by the system, sometimes indirectly. Third, values and rules. Ideas like fairness, privacy, safety, and laws made by governments. As engineers, asking, can we build this model is only step one. AI ethics asks the next question. Should we build it in this way, and what safeguards do we need? That mindset shift is what makes you a professional, not just a coder. Why is this suddenly such a big topic? Because AI is no longer locked inside research labs. It is in hospitals helping doctors, in banks scoring loans, in hiring systems filtering resumes, in classrooms grading work, and in apps we use daily. A small decision like which metric you optimize or which dataset you pick can affect thousands or even millions of people. Imagine a credit scoring model that is slightly biased. It might reject loans for a whole community again and again. Or a medical triage system that underestimates symptoms for one group and delays treatment. These are not just bugs. They are ethical failures. The key point is, once AI leaves your laptop and goes into production, your technical choices become real-world consequences. To make this more concrete, let us anchor AI ethics around a few core ideas. Fairness is about making sure the system does not treat certain groups worse without a valid reason. Transparency is about letting people understand, at least at a high level, how and why the system behaves the way it does. Accountability means that if something goes wrong, there is a clear person or team responsible, not a vague "the AI did it." Privacy is about respecting and protecting personal data, not treating it as free fuel. Safety and robustness are about making sure the system behaves reliably, even when inputs are noisy, incomplete, or slightly different from the training data. Most ethical issues you hear in the news can be mapped back to one or more of these pillars. Bias in AI does not mean the model is evil. It means the model has learned patterns from data that produce systematically worse outcomes for some groups. For example, if your training data has very few examples from a certain demographic, the model may perform poorly for them. If your features include something like postal code, that can act as a proxy for income or community and create indirect discrimination. If your loss function only cares about overall accuracy or profit, the model may sacrifice one group to improve the majority. As engineers, you can act against this. Inspect data distributions by group. Use fairness metrics like equal opportunity or demographic parity. Where relevant, compare model performance across subgroups, not just overall. And remember, saying the model learned it from the data does not remove your responsibility. You chose that data. Most modern AI is data hungry. But from an ethics point of view, data is not just numbers. It is people's medical history, locations, chat logs, financial records, photos of their children. So we ask, A few key questions. Did the person give informed consent to use this data for this purpose? Are we collecting more data than we actually need, or can we minimize it? Can we anonymize direct identifiers like names and phone numbers, or at least pseudonymize them? For some high-risk uses, can we add differential privacy, which adds controlled noise, so that individual records cannot be easily recovered or re-identified? On top of that, basic security matters. A brilliant model with a weak database can leak sensitive information. Good AI engineers think of privacy and consent as design constraints, not afterthoughts. Many powerful models feel like black boxes, especially deep neural networks. But in many applications, people need to understand why the model behaves a certain way. That is where transparency and explainability come in. Transparency means we clearly document what the system does, what data it uses, what its limits are, and where it should not be used. Explainability adds another layer. It can be feature importance plots that show which factors influence the decision. It can be example-based explanations like, "We approved you because your profile is similar to these past approved cases." For image models, it might be saliency maps showing which parts of the image the model focused on. This is not just for users. As an engineer, you need these tools to debug weird model behavior instead of guessing in the dark. It is tempting to say the AI decided when something goes wrong. In reality, AI is a tool built and deployed by humans. Accountability means we can trace decisions back to responsible people and processes. For example, who chose the dataset? Who defined the objective function? Who approved the model for production use? Good teams define ownership clearly. Each model has an owner. There are logs of which model version was used, with which configuration, at what time, for which requests. There is also a plan for what to do if things go wrong, like rolling back to a previous version and investigating the root cause. Regulators care about this. Courts care about this. Your future employer will care too. Accountability is not about blame only. It is about having a mature process that can be inspected and improved. From an engineering point of view, safety and robustness are almost like security for models. Robustness means the model keeps behaving reasonably when inputs are noisy, slightly shifted, or incomplete. For example, a self-driving car model should still recognize a stop sign with some dirt on it. Adversarial examples are special inputs crafted to trick the model. A few carefully chosen pixels can make a classifier see a turtle as a rifle. In language models, certain prompts can jailbreak the system and make it ignore safety rules. There are also misuse risks, like using a generative model to write malware or targeted scams. To handle this, teams run adversarial tests and red teaming exercises, where they deliberately try to break their own system before an attacker does. They also set up monitoring in production to detect unusual patterns, like sudden spikes and strange inputs. Responsible AI is not just about correctness on a clean test set. It is about resilience in a messy world. A powerful pattern for high-risk systems is human in the loop. Instead of letting AI make final decisions alone, we use it as an assistant. For example, in a hospital, an AI system might flag suspicious scans, but a doctor reviews and confirms the diagnosis. In hiring, AI might shortlist candidates, but a human recruiter reviews the shortlist and can override it. In content moderation, AI filters obvious spam, but edge cases go to human reviewers. You can design several modes. AI suggests, human decides. Human and AI collaborate interactively. AI acts automatically, but a human monitors dashboards and can intervene or shut it down. Human in the loop reduces risk, builds trust, and also creates new jobs around oversight and review. When you design your next AI feature, ask yourself where the human should sit in the loop. Generative AI brings its own special set of ethical challenges. Large language models can hallucinate. They produce answers that sound correct but are factually wrong. If a student, a doctor, or a lawyer copies that answer without checking, the impact can be serious. Models can also generate deepfakes, where a person's face or voice is recreated in a realistic but fake way that can be used for misinformation, fraud, or harassment. Another question is intellectual property. Many models are trained on huge internet datasets that include copyrighted text, code, images, and music. There are open debates about what is fair use and what is not. Finally, generative models can produce harmful content like hate speech or self-harm instructions if safety layers are weak. So we add content filters, safety policies, and clear warnings. As a user and as a future builder, you should treat generative AI as a powerful but unreliable assistant that always needs human judgment and fact-checking. There is a lot of fear around AI taking jobs. The reality is more nuanced. AI is very good at well-defined, repetitive tasks. It is weaker at work that needs context, creativity, or complex human interaction. So, most jobs will not disappear completely, but the task mix inside them will change. For example, a customer support agent might use AI to draft responses quickly, but still handle complex or emotional calls personally. An analyst might use AI to generate first draft reports, then spend more time on interpretation and communication. Ethically, the questions are, how do we support workers when tasks get automated? Do companies give training for new roles like AI operations or monitoring? Do we design tools that augment humans instead of replacing them blindly? There are also wider effects, like recommendation systems creating filter bubbles or AI surveillance tools that track people too closely. Engineers alone cannot solve all of society, but you can design systems that respect humans instead of treating them as just data points. Because AI is now so powerful, governments are stepping in with regulations. Many follow a risk-based approach. Simple tools with low risk, like AI that cleans up spelling, face fewer rules. High-risk systems like AI used in critical infrastructure, medical decisions, or credit scoring must meet strict requirements around documentation, testing, and human oversight. At the same time, privacy laws already limit how you collect and process personal data. Consumer protection and product safety laws can also apply if your AI harms someone. For an engineer, this means compliance becomes part of your job. You need to document what the model does, what data it uses, what its known limitations are, and in which context it should or should not be used. Working with legal and policy teams will be normal in an AI career. It is not a blocker. It is a safety net. Ethics is not a final check at the end of the project. It runs across the whole lifecycle. At problem framing, you ask, is AI the right solution here? And who might be hurt if it fails? During data collection, you consider consent, representation, and quality. When training, you add fairness tests and robustness checks, not just accuracy metrics. During evaluation, you test the model on different groups and edge cases, and you measure more than one metric. In deployment, you control who can access the model, what rate limits you have, and how you will monitor it. In maintenance, you watch for data drift and retrain when the world changes. You can imagine adding ethical checkpoints to your usual engineering pipeline. For example, no model goes live without a short model card, a bias check, and a rollback plan. That is what mature AI practice looks like. Let us turn this into everyday habits you can actually use. Before starting a new model, write down in one paragraph who benefits and who might be harmed. This simple question often reveals blind spots. While building, maintain a small risk log. If you notice skewed data, note it and think of mitigation. Add fairness and robustness tests alongside your unit tests. Treat them as part of quality, not something optional. Before shipping, ask a few peers to review not only the code, but also the ethical risks. Can someone abuse this system? Are we warning users about limitations clearly? After shipping, look at traffic. Are certain groups getting strange results? Did we see any attempts to misuse the system? These are not huge tasks. They are small habits that, over time, make you the kind of engineer companies trust with serious systems. The good news is you do not have to invent everything from scratch. There are tools and frameworks for responsible AI. Fairness dashboards can show performance across different demographic groups and highlight where the model struggles. Privacy libraries help with techniques like differential privacy, secure aggregation, or federated learning, where data stays on device. Interpretability tools like feature importance, partial dependence plots, and local explanation methods help you peek inside models. On the process side, model cards give a structured template to describe what the model does, what data it used, and where it should not be applied. Data sheets do something similar for datasets, documenting how the data was collected and cleaned. Many companies are standardizing these tools so that ethics is built into their normal workflow. Learning these tools now will make you much stronger in the job market. One of the best ways to build an ethics mindset is to treat every AI system you see as a case study. Take a hiring recommendation tool. What problem is it solving? Maybe it is ranking resumes. Then ask, what data is it using? Old hiring decisions. If those decisions were biased in the past, the model will learn that bias. Who is harmed if it fails? Probably candidates from underrepresented groups. Is there a way to appeal the decision? Now repeat that thinking for a credit scoring model or a medical triage assistant. Wired like this, your brain stops seeing AI as magic and starts seeing it as systems with goals, data, assumptions, and impact. This habit will help you debug not only ethics problems, but also pure technical ones, because you always think in terms of real-world behavior. The importance of AI ethics is only going to increase. Models are getting more capable. Companies are putting more money behind AI products. Regulators are watching more closely. This creates new roles, like AI safety engineer, AI governance specialist, or responsible AI lead. But even if you stay a classic machine learning engineer, ethics knowledge will be part of your profile. Your role is not to solve all moral problems of humanity. Your role is to design, test, and deploy systems in a way that respects users, follows laws, and reduces avoidable harm. That means speaking up when something feels wrong, asking for better data, pushing for more testing, and being honest about limitations. In the long run, engineers who take ethics seriously protect not only the public, but also their own careers and reputations. Let us wrap up. AI ethics is simply about building useful systems that avoid avoidable harm. We looked at core pillars like fairness, transparency, accountability, privacy, safety, and human oversight. We saw how ethics sits inside every part of the pipeline, from problem framing to deployment and maintenance. The main idea is, as an AI engineer, you are not just optimizing a metric on a dataset. You are shaping how real people experience technology. Before we close, I want you to think about two questions. First, In what kinds of systems would you personally refuse to let AI have full control without a human? Second, what is one simple ethical check you would promise to include in every AI project you work on? These answers will shape the kind of engineer you become. Hope as future AI engineers and AI learners, you will create a world with humanity on your mind. We as humans have a wider role to play in this new world. To learn more about AI, get new updates, and access free learning resources, visit www.thegeniuscircuit.com. Not only curated for engineers or developers, even if you are in a non-technical or semi-technical role, Genius Circuit has something for you to learn about this new era.